All right, welcome everybody. I'm going to give a short talk on grad school. A lot of undergraduates think that graduate school must be like undergraduate, but worse, right? Like, what is the cost of an education at like Harvard these days? Cost to go to Harvard? It's like 70,000 or some like ridiculous number. Like 80. Oh my gosh! Oh no. Okay. So they're waiving tuition. Okay. I was about to say it's 85,000 a year now. It's a modest. Okay, no, it is 80,000 a year. Okay. So students though, that previous thing said if your parents make less than 80,000 a year, we're not going to charge them every dollar they make before taxes to go to Harvard. So yay, go Harvard. Yeah, 80,000 a year. So that's presumably why a lot of you guys are in community college, right? Is because community college is not $80,000 a year. And so students will sort of say like, well, if undergraduate's that much, how much is grad school? And grad school, must clearly be, I don't even know if they have the grad school in here, must be worse. But here's the thing. Nobody I knew at UC San Diego Computer Science grad school paid tuition unless they wanted to for whatever reason. Like some of them, they paid tuition because like they were working for like a defense contractor and the defense contractor was like paying for their master's degree. And so they paid, but they didn't pay, like somebody else was paying. Right. And so nobody I knew paid tuition. So you might be like extrapolating like, oh, it'll be another 80,000 a year. Nope. Nobody paid. In fact, I got paid money to go to grad school. I paid no tuition. And I made enough money to cover my housing, my food, my gas, have a little bit of pocket change to, watch a movie once every 3 months or something like that. So the reason for that is because UC San Diego and similar institutions are what are called R1 institutions, the top tier research institutions. Fresno State actually just last week, I think, got classified, or maybe that was the announcement, got reclassified as an R2 institution. So they moved up. They're now a tier 2 research institution, which means they're pulling in millions and millions of dollars a year in research funding. Where does that money go? A lot of it goes to graduate students because graduate students are the bones of a university. They're what kind of make a university work. When a professor gets a NSF grant to make a new product to detect ChatGPT usage, it's very common for them to take the money and be like, this part's mine. And then this is the part that's actually going to be used to implement it. And then they pass that off to a grad student and maybe a team of undergraduates or something like that actually do the work. And graduate students oftentimes teach classes. At UC San Diego, we weren't allowed to teach classes, but we could teach discussion sections, which is almost an academic difference as to, it's not a lecture, it's a discussion section, but it's still Monday, Wednesday, Friday. I had Friday. You know what I mean? It's like, but technically professors had to teach their classes at UCSD. You couldn't just pawn off the entire thing on grad students. At some universities, yeah, the professor shows up the first day. Is like, hi, nice to meet you all. This is my graduate student that's going to be teaching for me. Bye. And so you're like, but I signed up for this class because you made Unix and stuff, and they just peace out. So graduate students make the universities go. And so if you're in grad school, if you teach or if you do research, at least at my institution, you paid no tuition and you got cash. And the best thing about that is that, if you did research, then you basically had your thesis kind of like handed to you like, hey, if you want to get a master's degree, one of the common ways you can get a master's degree is by writing like a 40-page thesis. Well, just write it on the thing that you've been doing for the past 2 years and publish it. And you do a little defense, but all the people on the defense have been working with you this entire time. And there you go, stamp, you get a master's degree. There's other routes into getting master's degrees. There's oftentimes 5-year BSMS programs where it's just like a 5-year. It's like you're an undergraduate for 5 years almost, except that last year you're taking graduate level courses instead of undergraduate. I highly recommend everybody do that because by the time you finish your undergraduate education, you're going to have taken a lot of classes at sort of a superficial level once. When you go to grad school, you take operating systems again, but at a deeper level. You take algorithms again, but at a deeper level. And you actually really start understanding the subjects a lot better. And and then the rest of the classes, other than those core classes, are oftentimes what I'm about to show you now. We would do a lot of what's called peer review. So I am a reviewer for SIGC, and I'm not going to show the papers that I'm reviewing because this is being recorded right now. But if I were to click on this, let's see if I can hide the papers that I have. There we go. Yeah, so I could click on the paper, download the paper, and then I can then I'm going to read it. And so for all of you guys, I'm going to kind of explain to you the peer review process. And so what you do, again, let me make sure that this is hidden. All right. So basically, this is what a peer review looks like. And this is what you do in grad school. A lot of my classes in grad school were just 12 people sitting around a table. Every week, the professor is like, we're going to read this paper. And you have to read it or, he gets mad at you. So, but it's like, it's pretty chill. You just, and you're reading papers on a topic, like you sign up for like advanced topics in operating systems or compilers or something. And he gives you like, some of them are like foundational papers. Some of them are like, papers you need to know. Some of them are like, pre-published like things that are coming out, and so you're reading things like at the forefront of human knowledge. And that's kind of a cool experience. And then sometimes you do peer review when you're in grad school as well. And the professor will sit there and take notes and kind of outsource the peer review maybe sometimes. And, it's like, oh, really? We're missing the axis labels on which one? Table 3.1. Okay. It's missing the conclusion section. Really? Oh, okay. Well, you didn't read that. Okay. And then they use that in their peer review. So this is what peer review looks like. So what you do is you summarize the paper. You give your familiarity on it. Did they motivate the research? Did they have a good job doing prior work, which kind of situates their paper in relation to other papers in the past? You do like a literature search, and they have good citations and things like that. Is their methodology good? Did they present clear evidence showing that their approach was successful? What impact does this paper have? And is the presentation good? Some like the worst on presentation that I saw was they had some sort of like disastrous formatting problem, and so all of the columns of text were printed on top of each other. And I'm just like, I don't know what you want from me on this, man. I cannot read anything. Like literally all 4 columns were superimposed on top of each other. I'm like, I can't recommend this for publication because it is literally illegible. And then at the end, this is the most important thing. You give a rating: must accept, should accept, might reject, should reject, must reject. And typically every paper is going to have 3 people reading it. I don't get to see their reviews until I review it. And then we get a look at our scores. And if there's discrepancies, like if one person's like, we must accept this paper, one person's like, we must reject this paper, then we're like, why? What's the point of this? What's the point of disagreement here? And maybe one person's like, well, their prior work wasn't good. There's this landmark paper they should have cited and they didn't cite it. And it's like, well, is that grounds for, and you like have a conversation about like, is that deadly? I mean, it's like they did cite 3 papers. They just didn't cite the paper you wanted. Yeah, and you kind of have a discussion about it. And then you write a little essay here on your overall thoughts on the paper. And then the person who's kind of the chair of that committee will sort of synthesize everybody's reports together and say, all right, we're going to recommend rejection on this paper. And here are the reasons why. If you're going to resubmit, you should probably add this citation to your prior work. And, don't have 4 columns superimposed on top of each other. That was a problem, and things like that. And then if you have some notes for the program committee, like, I think this was written by ChatGPT, that doesn't go to the author, right? That only goes to the other members of the program committee. So I just wanted to share that to you. I'm going to be doing peer review over the weekend. And finally, on grad school, there's one other thing I wanted to say. usually you get straight A's. It's kind of unusual to not get an A in a grad class. The only classes where they are like curved around a C or something like that are like those core classes that I was telling you about, like algorithms. Like I think like they failed like a large chunk of my algorithms class. It was hard, like, and you think that like, okay, well, if undergraduate's hard, if CSI 40s is hard, then graduate school must be like mega galaxy brain difficult. But in reality, it's easier than undergrad because most classes are just like 12 people sitting around a table with a professor. Sometimes the professor talks about something that they're interested in. Sometimes you read papers and you just kind of show up. You do what's expected of you. You read the papers, you contribute, you get an A. In those kinds of classes, if you get a B, that's like getting a D. Like you goofed up somewhere, and if you get a C, that's like an F. Like, oh my gosh. The only people to get Fs are like the people who just don't show up. Like, where is that person? I don't know. Did they do the project? Nope. Okay, well, I guess they get an F. But like, if you try, like, generally speaking, like you just get rubber stamp A's for everything. So I would highly, highly encourage all of you guys to go to grad school. Do you have to join the call? I'm interested after work Saturday night. Yeah, we can work that out. There aren't many seats, yeah, and so getting into grad school could be a thing. My advice is to do well, get good grades. In general, if you get like a 3.5 or better, somewhere in that ballpark, as an undergraduate, like you can get into grad school. Maybe not the grad school you want. Like I applied to MIT and I didn't get in. Such is life. But I actually asked them. I'm like, hey, why did I not get in? They're like, no particular reason. Like your grades were fine, your SAT was fine, your test scores are fine, everything's fine. We just get a lot of applicants. I'm like, it's fair. But so you might get into like not your first choice of school, but yeah, Mick Curley was saying that at Fresno State, the grad program there, like people don't pay tuition either, unless you want to. So yeah, just apply around. It's I highly recommend it. Like I really felt like grad school is beneficial to me, just as like a professional software engineer. Like I just felt like I understood everything a lot better. I went from having like an okay understanding of everything to like a pretty good understanding of everything. Like, all right, I feel pretty solid now. And then all of those like paper reading classes and things like that, like I actually felt like I'm kind of like kind of surfing a wave at the forefront of human knowledge. Like you're just kind of cruising right there along. You're reading preprint, papers that aren't even out yet. It's kind of a cool feeling. So if you, especially if you get a good graduate advisor, like grad school is pretty enjoyable. Like I had a good time in there. I could have graduated earlier, but I was actually just enjoying being in grad school. Like it was just a fun experience. I was learning things, getting paid to learn. I was doing research, getting paid to do research. I was teaching and getting paid to teach, which I guess everyone does, but it was a good experience learning how to teach. So that's my spiel on grad school. Everybody should go to grad school.